Hello everyone and welcome to CourseWeaver's authoring tutorial videos for the LON-CAPA system. In this video we're going to look at creating a simple matching problem in the LON-CAPA authoring space. To get started, let's jump to our authoring space and create a new problem. Once again, remember that when we publish something in LON-CAPA, it can no longer be moved or deleted. So make sure you're creating it in the directory you'd like it to remain in. I'm going to choose the same directory as my previous problem. I then click New Problem, give it a name, Matching Practice, click Go, I confirm, and once again I'm at the template page. If I scroll down, I can see there are actually two different matching response type problems. Let me click on an example and see what we've got here. Okay. Then let me check out option response. Oops, clicked on true and false. This looks like the one I want. Nice and simple. I'm going to choose option response matching. Now that I'm ready, I'm going to create my problem. Just like my previous problem, I can click New Randomization to see that the problem is already functioning, meaning most likely I simply need to change the text. Let's do that by jumping into the colorful editor. I'm going to start by changing the question. Let's make this a chemistry question. Match the row in the periodic table to the element. Oops, here we go. Then I'm going to scroll down and I'm going to change my foils. Let's do hydrogen, and then oxygen, and then how about sulfur, and how about potassium. Great. If I click Save and View, I can see my responses here. However, my options are still green, red, and blue, which isn't exactly what I want. So I'm going to jump back into the colorful editor, and we're going to look at how we actually change our options. We scroll down to our select options, and now we see we have the option to add something new, like let's say row 1 of the periodic table. We can also delete an option. When we're finished, we click Save and Edit. However, this way kind of takes a long time, and there's an easier way to do it, but it's going to require us to jump into the XML. Let's click Edit XML and see if we can't figure this out. I see foil group and I see my options green, blue, red. This is where I can change them to make them into what I'd really like. Row 1, row 2, row 3. Now, hydrogen is found in row 1. I know oxygen is in row 2. Sulfur is in row 3. And wait a second, potassium is in row 4, but I don't have that. I need to add this response up here, so I do a comma and add in row 4, and then click Save and View. And it looks like it worked. I see my options, row 1, 2, 3, 4. I can randomize. And it looks like my problem's looking pretty good. Keep in mind, if you want to add foils or remove foils, or maybe even just change the amount of foils shown, we can re-enter the colorful editor, scroll down, we can change the maximum number of foils shown. Why don't we change it to 5? And then if we scroll down just underneath our last foil, we can add another option response foil. Instead of doing this though, let's look at a little bit more of a challenging concept. Let's add what's called a collection of similar foils. Let's select it and hit Save and Edit. And here we go. I see a concept grouped foils. This has essentially created a concept group where only one of the responses from this collection will be shown. This allows us to group ideas into foil collections to ensure at least one of them is presented to the students. However, each student will still receive a different one. Let's look at an example. Let's give our collection a concept name. Why don't we say this is row 4. This would be foil 5. Correct option is row 4. And then let's see, element from row 4, we have xenon. But you know what? I want to add more to this. I want to add another option response. So I click Save and Edit. I scroll back down. We'll add foil 6, row 4, and why don't we add tin? And then let's click Save and View. Now we can see here's our xenon with row 4. However, if we hit new randomization, we see xenon again. And I see tin. Okay. New randomization. So essentially what LON-CAPA is going to be doing is not only randomizing the position of all of these elements, but it's going to be randomizing between tin and xenon for this one specific concept. Organizing your matching problems into concept groups called collections of similar foils is a powerful way to not only randomize the order, but randomize the concepts. I hope you enjoyed the video, and if you have any questions, please contact us at info@CourseWeaver.com.